students. Last class we have learned solids and the classification of solids and the difference between crystalline and the amorphous solid. Today we will discuss about classification of crystalline solids. Okay, so in crystalline solid classified into 5 different types. First one is ionic crystals, next one is covalent crystal, third one is molecular crystal, fourth one is metallic crystal, fifth one is atomic solids. Okay, first of all, ionic crystal. Ionic solids, what does mean that ionic? That means ionic means it consists of ions. Okay, they are positively charged cations, positive charged particle and the negatively charged particle. Okay, so positive charged particles are called as cations and the negatively charged particles are called the anion, isn't it? So first of all, ionic solid. The structural units of the ionic crystal are cations and anions. That means ionic solids consist of both the cation and the anion. Okay, then they are bound together by strong electrostatic attractive force. Okay, they are bound together by strong electrostatic attractive force. Okay, then this cations are surrounded by as many anions as possible and vice versa. That means cations surrounded by anions and anions surrounded by cations. For example, this is a structure of sodium chloride. Okay, so sodium chloride, it consists of sodium plus ion and the Cl minus ions. Sodium plus ion and the Cl minus. You see the picture. Let us imagine this is the sodium plus ion. Okay, in this red color ball denoted to the Cl minus ion. Okay, so for example, this is the sodium plus ion, means it was fully surrounded by red color. What is the red color ion denoted to? Chlorine, isn't it? So all the positive ions surrounded by negative ion. Okay, suppose this is the negative ion. Okay, so this negative ion surrounded by all positive ion, isn't it? So in this ionic crystals possess definite crystal structure. Then many solids are cubic closed packed. Okay, cubic closed packed. For example, this is the structure of sodium chloride. This is the one of the important example of ionic crystal. Okay. Next one, characteristics of ionic solids. Okay. So first of all the ionic solids are hard and brittle. Okay. So ionic solids have the high melting point. They have a high melting point, and this solid do not conduct electricity. Ionic solids do not conduct electricity because the ions are fixed in their lattice position. Okay, ionic solid do not conduct electricity. Suppose this ionic solids are dissolved in the liquid, any solution, so it converts into the solution, isn't it? So ionic solids are mixed, dissolved in any other solvent, so it converts to the solution. Okay, so in case if it is the liquid or the fused condition, so this fused or liquid condition, ionic solids do conduct electricity. Okay, so in the solid state it cannot conduct electricity, but in the liquid and the fused state, that means molten state, it conduct electricity. Okay, then they are hard as only strong external force can change the relative positions of ion, because all the ions are held together in very tightly packed. Okay, therefore it was very hard to remove the crystal lattice. Okay, these are the characteristics of ionic solids. Okay, do you understand? Next one is the covalent solids. In this covalent solids, the constituents, that means atoms. The atoms are bound together in a three-dimensional network, that is 3D dimension. 3D. Okay, three-dimensional network entirely by covalent bonds. In the covalent bonds. Okay, covalent solid bound in the covalent bond. Example, diamond. Another one is silicon carbide. Okay, next the characteristics of covalent solid. First one is very hard. Okay, so example is a diamond, isn't it? First point, very hard. Next one is it have the high melting point. In this covalent solid have high melting point, and also this covalent compounds have the poor thermal and electrical conductors. Okay, poor thermal and the electrical conductors. This is the covalent solid. Okay, next one is the molecular solid. In this molecular solids, their constants are neutral molecule. Okay, they are held together by weak van der Waals forces. Okay, weak van der Waals forces. So first of all, their constants are neutral molecules. They are held together by weak van der Waals forces. Therefore, it was easily breakable. Okay, that's the reason. Example, naphthalene and the anthracene. Okay, then characteristics பார்த்தோம் அப்படின்னா, first point, molecular solids have soft. Okay, second one, it do not conduct electricity. It's molecular solids do not conduct electricity. Okay, then these molecular solids are further classified into three types. They are non-polar molecular solids, then polar molecular solid. Next one is the hydrogen bonded molecular solids. Okay, first of all, non-polar molecular solid. In this non-polar molecular solid, the atoms are held together by weak dispersion forces or London forces. Okay, in this non-polar molecular solid, the atoms are held together by weak dispersion force or London force. Okay, next one, they have low melting point. They have low melting point. At room temperature, it may be present in the gaseous condition or the liquid condition. At room temperature, it may be present in the gaseous or liquid condition. Example, naphthalene and anthracene. Okay, next one is the polar molecular solid. So, in this polar molecular solid, the constants are formed by polar covalent bonds. Okay, next one, they are held together by relatively strong dipole-dipole interaction. Strong dipole-dipole interaction. Okay, and also they have a high melting point. In this polar molecular solid have high melting point. Example, solid carbon dioxide and the ammonia. Okay, so in this polar molecular solids held together by strong dipole-dipole interaction, and also they have high melting point. Example, solid carbon dioxide and NH3. Last one is hydrogen bonded molecular solid. So here in this compound, the constants are held together by hydrogen bond. The constants are held together by hydrogen bond. This type of molecule also soft. Okay, salt, soft, and also solid in the room temperature. It may be solid in the room temperature. Example, solid ice and glucose. Okay, students. So today we have learned crystalline classification of crystalline solids and examples. Okay, students. Hope you have understood. Thank you.